Right. So let's start lecture number 5, chapter 3. Chapter 3 is about the equilibrium of a particle, right? As in the beginning, we discussed that there is a difference between the particle and rigid body. In particle, a particle can have a translatory motion only. Translatory motion mean the motion can be on a straight line or it can be on a curved path, right? But not the rotary motion. I mean, particle cannot rotate about its own axis, whereas the rigid. That's why it cannot produce any moment. Whereas in case of rigid body can have a in addition to the translatory motion, it can also have a rotary motion. So there will be moment also in case of rigid body. So that's the main difference between the particle and equilibrium of a particle and equilibrium of a rigid body. So in short, in equilibrium of a particle, we'll just consider the forces only, right? Forces only, whereas in case of equilibrium of a rigid body, both forces as well as moment will be considered. So let's define the condition for the equilibrium of a particle. Now, equilibrium of a particle, the main condition is that if there is a static body which is not moving, so that means uh, it will remain in rest. That means there is no unbalanced force. Basically, the equilibrium condition is the same as Newton's first law, that if there is a body which is at rest, it will remain at rest if there is no unbalanced force. Similarly, if a body is moving in a constant velocity, then it will keep on continue if there is no unbalanced force. Mathematically, we can say no unbalanced force means the sum of all the forces that are acting on the body is equal to zero, right? But we are concerned here equilibrium, uh, static equilibrium. Will not consider the dynamic equilibrium where the velocity, the body which have the constant velocity. So we'll just focus on static equilibrium, right? Where the body is at rest. So this is the fundamental condition for equilibrium, that sum of all the forces that are acting on a body is equal to zero. So that's called the condition for equilibrium. Now the the system of forces, they can be analyzed in a two dimension. Two dimension mean we say coplanar forces, whereas the third way is the equilibrium in three dimension. If we consider all the three dimension of a body, it's up to us. Sometimes the two dimensional analysis is enough to describe the behavior of a system, whereas sometimes we need to describe the behavior of a system in three dimension. So in this class, we'll discuss both equilibrium in two dimension as well as equilibrium in three dimension. There is no much difference between 2D and 3D. You will see that. So let's start with the coplanar force system, which is also called a 2D system, right? In two-dimensional system, let's say here two dimension mean just the x-axis and y-axis. So if we have, let's say, a particle, and on that particle four forces are acting, let's say F1, F2, F3 and F4, right? And this body is in equilibrium. Equilibrium system mean that this body is in static condition, it is not moving. So that we can say then that the sum of all the forces, sum of F should be equal to zero. So that's the fundamental condition of the equilibrium. But each component has two component, right? Sum of all the forces equal to zero, but every force like F1 has two component. One of the component is along x-axis, we can say F1x, similarly F1y, right? F1y. Similarly F2 has two component, one is along Fx, one is along Fy, so F2x, F2y. Similarly F3 has two component, one is F3x, F3y. Similarly this force has two component, one is F4x, F4y. So all the forces, they have two component. We can say then we can sum up the forces on the x-axis as well as on the y-axis. So in order to satisfy this equation, sum of fx I component and sum of fy j component is equal to zero. Then each one should also be equal to 0, right? Sum of all the fx is equal to 0, sum of all the y is equal to 0. So that means in a two-dimensional force system, we have two equation, equation 1 and equation 2. So if we have two equation, then how many maximum number of unknown we can figure out? If we have two equation, how many unknown forces we can figure out in two dimensions?
Two, sir.
Two forces. So that depend upon the number of equations, that how many number of equations are available. So if there are two number of equations, that means the maximum number of unknown in a force system we can figure out is two unknown forces. So we any system which is in equilibrium, that must satisfy these two equations, that sum of all the fx component should be equal to 0, sum of all the y component should be equal to 0. Now, next is what is the procedure for analysis relating to the equilibrium. So first of all, for any type of question that is related to equilibrium or force system, first of all, try to draw the free body diagram. In free body diagram, the first step is to establish x, y axis in any suitable direction. Basically, suitable direction mean that depends on the direction of the body. Let's say this is a block. Let's say this is a block. So we can choose the coordinate axis of this block, let's say y axis and x axis, right? Similarly, let's say that block is on any inclined surface. Let's say this one is an inclined surface. For this case, we may choose that this is the x axis and this is our y axis. Similarly, let's say if the block is placed in this direction, let's say this direction orientation, and this is our block. Now, for this case, we may choose that this is our x axis and this is our y axis. So that depends, you have to choose a suitable orientation for the y and x axis. Now, sometimes instead of choosing the x axis or y axis, we may choose the normal and tangential axis. We call it NT, normal and tangential axis. Now, tangential axis is always along the axis of the body. For example, this is along the axis of the body. So instead of choosing the x-axis, sometimes we may choose tangent axis, and perpendicular to that tangent axis we call the normal axis. Similarly, this axis which is along the axis of the body, we may choose it as a tangent axis, and the perpendicular to this axis is a normal axis. But generally, in most of the cases, I mean, the easiest way is to choose XY coordinate system. That's very easy and convenient. And then after you choose the x and y coordinates, then you have to label all the known and unknown forces, I mean, from that body. Let's say this is a body, then on body what are the known forces and what are the unknown forces. And then let's say you don't know the direction of the unknown force. Let's say this is the unknown force and you don't know the direction of the force, that what is exactly the direction of this force. Then you can assume any direction. Let's say you assume this direction, and then you calculate the force. Let's say this is force F. You calculate that force, and that value comes out to be negative. Let's say that value come out to be negative 50 Newton. So that a negative sign will indicate that the direction you have chosen is not correct. The actual direction of the force is opposite to you have chosen. So instead of in this direction, the direction is in the opposite direction. So this negative sign will indicate you that basically you have chosen the reverse direction, right? So you can assume the direction of any unknown force. So after you calculate the value, the positive or negative value will indicate that whether the selection of your direction is right or wrong, right? And then you apply the equilibrium equation. So you have, since this is a 2D system, so you have to apply these two equations. This is the first equation and this is the second equation. So you have to apply two equation of equilibrium. That means you will have two equation and you can calculate two unknown forces for that case, right? And then similarly, this is the, I already explained about that, right? So this is the procedure basically, and the remaining is practice. Remaining is just you have to practice as much as possible, right? It's up to you how much practice you perform for calculating the free body diagram, for calculating the unknown forces, right? So let's start from the very fundamental. Let's say this is an arrangement which is shown in the figure 3.3a, and a mass of 6 kg. I mean the sphere has a mass of 6 kg, this one, and is supported as shown. So this is the support from A to B and then C, and here is a knot, and then there is a spring, and then the sphere. The question is, draw a free body diagram of this sphere, and then the code CE. So this is the code CE, and then the knot at C. So then this knot at C. So very simple, like if you want to draw the free body diagram of this sphere, that means this is our sphere. So weight is acting downward, whereas this force EC, let's say this is force EC, FEC is acting upward, right? And similarly, this code, one end is connected with the weight, whereas the tension in the code, I mean this FEC, is basically equal to that weight, right? That is equal to that weight. Similarly, if you try to draw the free body diagram of this node, let's say node C, right? So for that node C, one force is downward, which is equal to FEC, right? That force FEC, and then one force is CB. This is CB, right? And then another force is the spring force, CD. Spring force, CD. So this is the free body diagram of that node, right? So this is the free body diagram of the sphere. This is the free body diagram of the node, and then this is the free body diagram of that node C, right? And let's try to solve one more example. Let's say this is problem from the exercise book 3-3. The problem says that the lift sling is used to hoist a container. Now this is a container. You know that these containers are used to carry, even they are used for import or export of the goods, and they can carry very huge volume of the items. So normally at the dry port, these containers are loaded or unloaded using such type of arrangement. There is a crane on that, right? This sling is connected with that overhead crane, and then you can either pick that container or you can put that container. The question is relating to that. In that case, the weight is 500 kg. So the weight of that container is 500 kg. So weight is given, right? Determine the force in each of the cables AB and AC. So what is the force in these cable AB as well as AC, right? As a function of theta. So you have to figure out the force as a function of theta. Now then says if the maximum tension allowed in each cable is, so the force, if you assume the force is 3.5 kilonewton, then what is the shortest length? What is the shortest length of cables AB and AC that can be used for the lift? The center of the gravity is located at G. So the center of gravity is shown. So for that case, first of all, you need to calculate these forces. So that means we have to draw which free body diagram, which particle we have to select to draw the free body diagram, because it has many particles. So which particle we should select?
Sir, we will select as in the center of body, G.
I mean G. You mean we'll select G to
Yes,
calculate
sir.
the, but how you will, how you will, interact or you will correlate this G with these unknown forces, because we have to calculate these unknown forces. One force is along, AB, one is along AC. So how you are going to select?
Sir, we will select A.
Yeah, we have to select basically A, because that force here, this force here is basically equal to the total weight. This is the total weight. I mean, whatever is the total weight, like whatever is the total weight downward, then you have to apply that much force to carry the weight in upward direction. So basically this force is equal to this weight. And how much is that weight? That weight is 500 times 9.8, 9.81, right? Because this is at the terminal point. So that force is basically equal to the whole weight, right? So we can draw the free body diagram of point A, right? At point A, we have a force in the upward direction, we called F, and then we have one of the force is, let's say, uh, FAB. Let's say we have given the name FAB, and then another force is FAC, right? Another force is FAC, right? And then we know that angle, let's say this is the angle with respect to x-axis, so this angle is theta. We know that because this one is making that angle with the x-axis. So the angle with the x-axis is theta. Again, this is also theta, right? So if we have the two component of these forces, let's say one of the component of this force will be FAB cos theta. Similarly, this component will be FAC cos theta. So what do you think? I mean, this component is FAC cos theta, and the other component will be again FAB cos theta. So do you think these forces are equal because the angle is same? So these forces are basically equal. I mean, if we apply the first equilibrium equation is sum of all the forces in x direction is equal to 0. So we just have two forces in the x direction. One is FAC cos theta, another one is FAB cos theta. So these are basically equal. So that means FAB cos theta will be cancelled out. So we'll have FAB equal to FAC. So both forces are equal basically. So that means, let's say we have given that name since both forces are equal. So let's say we say that force is, let's say, F2, right? Let's say that force is equal to F2. So then if we apply the second equation, right? If we apply the second equation means sum of all the forces in y direction is equal to 0. Then what will happen? What are the component in the y direction? One of the component is the weight, right? Weight and that total F which is acting in the y direction. So that is basically 500 times 9.8. So that called the in the y direction. So the other component, one of the component is this one in the y direction, and one component is this one. So both are acting in the negative y direction and one is acting in the positive direction. So positive should be equal to the other two component, which is equal to 2 times F2, because both are equal, 2 times F2 sine theta, right? Sine theta. So from here we can get that F2, right? So if you simplify, I mean, for this case, F1 mean if you multiply with the 9.8, then it will come out to be 4905 Newton. And we know that this is acting in upward direction, so it will have two component. Every force will have two component, one in the x direction, one in the y direction. Similarly, this force will have two component, one in the x direction, one in the y direction. And then we can apply the first one. From the first one, we can know that both forces are equal. So let's say we have given that name F because both forces are equal. So let's say this is F. Then if we apply the second equation, sum of all the forces in y direction. So in y direction, we have one force, this one, and then these two components. So that's minus 2F sine theta. So from here, we can figure out F is equal to this value, whereas 1 by sine theta is equal to cosecant theta. So this is the form of the force in terms of theta. The first part was that calculate these forces both are equal forces. So let's say we have given the name F in terms of theta. So that is in terms of theta. Now next point was to calculate the length of the chords. So how can we calculate the length of the chords from the previous example? I mean, we need to calculate the length of this chord, right? So to calculate the length of this chord, let's say this is 1.5, this is 1.5, and now they have mentioned the value of that force, that if the force is 3.5 kilonewton, that means if we put in the previous equation that value of 3.5 here, if we put that value 3.5, right, and then we can calculate that theta, right? If we put the value, right, what will be the value of the theta, right? 3.5 mean if we convert into newtons, that will be 3500, and if we put that value, then we can calculate the value of theta. So the theta value will be equal to 44.48 degree, right? So now it is very easy to calculate the length of that, because it is like this force, and we know that this length I mean this angle is we just calculated, that is 44.848 degree, right? And we know that um, this distance is 1.5, this distance is 1.5. So basically we want to calculate, this is point A, right? This is 0.8. We want to calculate this length, right? So how can we calculate this length? This is the hypotenuse, this is base. So we can use cos theta. I mean, this length will be equal to, let's say this length is AB. So that will be 1.5 by cos 44 point something. So you can say this length is 2 or 1.5. I think here we have to use 2. So that just a typing mistake. Here is instead of 1.2, let's say if we even take, let's say even the 2 as well, let's say. So you just have to divide with cos 44.48. So you will get the length of 2.8 meter, right? So is that clear? Right, you understand the problem?
सर ये 2 मीटर का
Yes, sir.
2 meter basically here is a typing error. I mean here instead of you can say 1.5, please use 2 meter length. Here is, that's a typing error. Here is 2 meter, here is also 2 meter, right?
ओके सर क्लियर है
Then let's try to solve another one. This is an example of spring. Let's say in that example, this is 3.17, problem 3.17. Determine the mass of each of two cylinder. So there are two cylinder. You need to calculate the mass of each of the two cylinder if they cause a sag of S 0.5 meter. So where is S? So where is, this is S, right? So S is 0.5 meter when suspended from the rings at A and B. Note that sag S is equal to 0 when the cylinders are removed. So basically initially you can see this was the arrangement, that these were the two rings, right? So when there were no cylinder, right, there was no cylinder, then S was equal to 0. I mean initially the spring was at this position. There was no value of S. S was equal to 0. This was the initial position of the ring. But when you connected these two cylinder, then there was a stretch in the spring. So this is the new location. This is the new location. So in this example, what you need to calculate is what is the mass of each of the cylinder, right? Based on the given data. Now you can see that this is a symmetric system. I mean, we can symmetric mean we can split that into two half, because both half they are basically the equal. If you calculate the one half, that will be equally same as the remaining half. So let's try to, let's say, focus on the left portion. Let's say uh, since we need to calculate the value of the cylinder, I mean cylinder weight or mass, so that means we have to focus on the ring A. So if we focus on the ring A, then the free body diagram of that ring A will be equal to, like, one of the force will be the weight of the cylinder. That will be the weight of the cylinder. Then one of the force will be FAB, right? FAB. And then one force is the spring force. This is the spring force. And let's say this is AC. That's force is AC. right? So now we need weight now. So we can calculate the value of that weight if we know, if we know these forces, right? But we don't know these forces. First of all, what we need to calculate is this force is basically the spring force. FAC is basically the spring force, and we know that that spring force is equal to which value? Spring force is equal to,
KX.
yeah, right. So spring force is basically equal to Kx, right? And K is given, which is 100 Newton per meter. And how to calculate the value of X? That's the point. X is basically the stretch in the spring. We have to calculate that what is the stretch in the spring. So we know that we can calculate like the length of the spring. What was the initial length of the spring and what is the new length of the spring? So the difference of the length, this was the previous length and this is the length when the cylinder is attached. So whatever is the difference of the length, that will be equal to the stretch produced in the spring. So what is the initial length? We can calculate from here. Like this is the initial length that this we want. Let's say this is L naught. This is the initial length. And we know how much is this? This is 1.5. Vertically is 1.5 from this point. Right? And what is horizontal 2? So what is L naught? L naught is 2 square plus 1.5 square, and then you take the square root. Anyone has the calculator? Let me see.
2.5.
2.5. Okay. So this length is equal to 2.5 meter, right? And then what is the new length now? So let's say if we include this one, what is the new length? For new length, the horizontal distance is same, 2 square. What about the vertical distance now? So this is 1.5 plus 0.5. So that means 4. So that means 8 under root. 8 under root is equal to how much?
2.82.
2.82, let's say. So how much is this stretch now? So what is the value of x? 0.
0.3.
Yeah,
0.32.
0.32, let's say. So this is the stretch. So that means now we can calculate the spring force. So the spring force here, that spring force is basically equal to K times 100 multiplied by the stretch, which is equal to 0.32. Right? So that will be the spring force. Now we need to calculate the weight. Now this spring force will have two components. One component will be acting along the x-axis and the one component will be acting along the y-axis. So basically this weight is equal to which component of the spring? This weight will be equal to which component of the spring?
Y component of this.
Y component, because this weight is equal to the y component of the spring. That means we have to apply the second equilibrium equation, that sum of all the forces in y direction is equal to 0. So then if we apply that equation, then is equal to W is equal to what is that value? If you multiply 100 with that's 32, about 32. That's a 32 sine theta. Sine, so we need that theta as well. So how to calculate that theta? So we need that theta as well, right? This theta. We know this length is 2 and the horizontal length is also 2. So how much is that angle? So if the length is equal, how much is that angle? 45. If the length are equal, then angle is equal to 45. So that means here 32 sine of 45. So that will be equal to the weight. So please calculate 32 sine of 45. What will be that?
22.6. 22.62.
How much?
22.62.
22.62 Newton, but we need the mass. So mass we have to divide with 9.81. So 22.62 divided by 9.81. So then you will get in kg, right?
2.30.
Right. So you can calculate that. How much is that? So first of all, we calculate the stretch length, then the unstretched, then we minus that. So that was the stretch in the spring. Then we calculated the spring force, and then the angle was 45 degree, and then we apply that, and we get the weight equal to 23.33, and then we divided with the 9.81. So the mass is 2.38 kg. So this is how we calculated the mass of each cylinder. So same will happen on the right hand side. So each cylinder will have mass of 2.38 kg. Right. Let's try to solve another one. This is very similar to that, slightly different. Let's say the springs on the rope assembly are originally stretched 1 feet. So the spring are stretched. So these spring are initially stretched 1 feet when theta is equal to 0. So where is theta? So this is theta. So when that theta is equal to 0 mean this rope was at horizontal position, right? So that means the theta is equal to 0. So at that time when the theta was equal to 0, then the stretch in the spring, let's say x naught, stretch in the spring was 1 feet, right? And determine the vertical force F. What is the value of this vertical force that must be supplied so that the angle is 30 degrees? So when the angle becomes 30 degree, then what is the value of this force? Right? We have to figure out this. You know that, I mean, if this rope start from here, this is the same force. The same force will go here. Similarly, if this rope start from here, the same force will go up to in that thing. So that means we can draw the free body diagram of that ring A. So if we try to draw the free body diagram of ring A, then the unknown force is F that we have to calculate. Then another force is this one. That's also a spring force. Let's say FAD. That force is FAD. And then there is another force FAB. Right? FAB. Right. So basically, since both are spring forces, so if we try to apply, let's say this is the angle theta, both angle is same. So what do you think? If they have the same angle, like it will have two component. One component will be like FAD cos theta, FAD cos theta, whereas the other component will also have FAB cos theta. Right? Both will have FAD cos theta and FAB cos theta. So if we apply the first condition, sum of all the forces of x direction is equal to 0, then the cos theta will cancel out. So that means FAB will equal to FAD. So that means both forces are equal, right? Both forces are equal. So that means FAD is equal to FAB. So both forces are equal. So let's say we can give the name and any force, let's say since both are equal, so let's say Fs. Since both forces are equal, so we can give a common name. Let's say Fs. So we need, in order to figure out this force F, we need to figure out the spring force, any of the spring force, because both are equal. So let's say if we can figure out one force, one spring force, then that is equal to the other spring force. And then we can apply the second equilibrium equation, which is equal to sum of all the forces in y direction is equal to 0. So first of all, we need to figure out the value of the spring force. So how can we figure out the value of the spring force? We know that the spring force is equal to kx, right? We know the original x naught, but what about when the angle is 30? How to calculate that stretch now? So that means I mean originally the length of that AB was this much, right? Originally the length of the AB, this rope, when the angle was 0, this was on the horizontal position. So the length was equal to 2 feet. Now, because of that force, this rope is in this direction when the angle is 30 degree, right? When the angle is 30 degree, then what is the new length? What is the new length? This one, AB. So this is angle is 30 degree. So we can apply, this is base and this is hypotenuse. So we can apply cos theta. I mean cos 30 is equal to 2 by AB, the length AB. So in other word, AB is equal to, what is the value of AB? 2 divided by cos theta is how much?
0.309.
2 divided by cos 30. So that's equal to 2.309. Yes, the value is 2.309. So what do you think? What is the stretch now? So how much is the value of this stretch? I mean this AB previously,
0.309.
yeah, right, 0.309. So when the angle was equal to 30, the stretch was 0.309. So what is the total stretch now? What is the total stretch? When the angle was 0, how much was the stretch? 1 feet. I mean, initially the stretch when the angle was 0, 1 feet. When the angle is 30 degree, now the stretch is 0.309. So how much is the total stretch? 1.30.
1.3.
Yeah, now is 1.309. So if we put here, K value is 30. So 30 multiplied by 1.309. So that will be equal to the spring force, which is equal to 30 multiplied by 1.309. So that value is basically equal to 39.27. 39.27, right? Pounds. So that's the spring force. So once you got that spring force, so now we can apply this second, the sum of all the forces in y direction is equal to 0. So which force is negative y direction? This is in the negative y direction. So this F unknown force, which is in the negative y direction, will be equal to 2 component of these forces. One component this one component this one. So that means 2 times, because both forces are equal, 2 times of the spring force sine, what was that angle? 30. And what is the value of the spring force? Spring force is 39.27, 39.27 times sine 30. So this way you can calculate the unknown force, this F. So if you simplify, you will get that value, right? So first of all, you got AB, and then the total stretch was equal to 1.31, and then you calculated the spring force. So once you got the spring force, you apply the F, this force, and finally you got that unknown force, 39.3 pounds, right? Right. So we just discussed equilibrium in 2D and how to calculate the problem related. So basically you have in 2D, you have to apply sum of all the forces is equal to 0, right? And in 2D, we have one of the equation is F sum of all the forces in X is equal to 0 and sum of all the forces in Y direction is equal to 0. Now, what about how to discuss the equilibrium in 3 dimension? So what is the major difference between the equilibrium in 2 dimension and equilibrium in 3 dimension? That in 3 dimension, we have to consider one more direction of as well. I mean, we have to include sum of all the forces in Z direction is equal to 0, right? That's called the 3 dimensional system. So you can see here we have the 3 dimensional system, x-axis, y-axis, and z-axis as well. So we have included the z-axis now for the 3 dimensional cases. Similarly, we have to apply the same equation that sum of all the forces should be equal to 0. Now we have 3 coordinate system, then we'll include the z-axis as well. And then in order to satisfy this equation, all the 3 terms should be equal to 0. I mean, sum of all the fx sum of all the forces in y direction and sum of all the forces in z direction. Please, there is a typing mistake. This is not y, this is z. Sum of all the forces in z direction should be equal to 0. So that means now we have three set of forces. Instead of one set of forces, now we have three set of forces. So that means at a time, how many unknown forces we can calculate now?
3.
Yeah, now we can calculate three forces, but in a two-dimensional system, we can calculate a maximum of two unknown forces because we have two equations. Now we have three equations. Now I can calculate three unknown forces, right? And what is the procedure for this one? The procedure is same that you have to draw the free body diagram, then you have to choose a suitable XY orientation to draw the free body diagram, and then if you don't know the direction of the unknown force, then you can assume the direction, and then if you calculate that the assumed direction, then the value come out to be negative, then the actual direction is reverse to that direction that you have selected, right? And then you apply the three equilibrium equation. But there is a slightly difference in the analysis between the two-dimensional and three-dimensional. The main difference is that a two-dimensional system is analyzed using the scalar analysis. I mean, we have used the angles, we have used the trigonometry in 2D, right? Trigonometry angles for the 2D. But the 3D system is easily dealt by using the Cartesian vector. As even in the previous class, when we discussed just forces, we saw that in three dimension, we use vectors, right? Any force we first convert into vectors, and then whether we have to calculate the resultant force, then we have to add all the force vector, right? To convert a scalar force into a vector, we need a unit vector, right? So if we multiply any force with a unit vector, that will become a vector force. So three dimension, that's the main difference between the two dimension and three dimension. So in three dimension, we'll use the Cartesian vectors or the vector analysis. So that's the main difference. Otherwise, remaining procedure is the same. So let's try to practice some example. You will understand. For example, here you can see in this example that determine the tension in each cord used to support 100 kg crate and stretch in the spring. So you can see that this is basically a crate that has a weight of 100 kg. To support that crate, there are so many forces. For example, one of the string is this one. So it has supported that, and then the cord, one end of the cord is connected with the sport D, and then the sport C, and then the sport B. So the question is determine each force which is used to support that crate. So again, we have to select first that which point we have to select to draw the free body diagram. What do you think? Which point we have to select?
Point A.
Point A. In order to calculate all the unknown forces, so how many maximum forces we can calculate?
3.
3, because we have three set of equations, so maximum number of unknown forces we can calculate is 3. So in this example, how many forces are there? One of the force is weight, right? And weight is, we know it is already acted in the negative z direction. So that means if the weight is 100, that means 100 multiplied by 9.8, right? 9.8. Now this is negative k direction. We already know this is negative k direction. Similarly, this spring force is very easy to give the direction for the spring force, because that spring force is exactly acting on the x direction, right? This is exactly acting on the x direction. So for that spring force, we already know we can easily convert into vectors because this is on the I direction, positive I direction, right? And for the force FAC, I mean, if first of all you try to draw the free body diagram of the point A. So for point A, one of the force was FAD, right? FAD, and then the second force was the weight, right? And then FCA. right? FCA,
Excuse me, sir.
and then FAB.
Sir?
Yes, do you have any
Uh,
question?
नो सर, मैंने आपसे वो कहना था कि सर आज हमारा क्विज होगा ना, क्विज और असाइनमेंट?
नहीं, आज नहीं होगा, हम कल कर लेते हैं.
अच्छा,
Is it
आज नहीं
okay?
होगा
You want to take today?
सर? आपने आज का कहा था मेरे साथ.
Okay, if you are ready, then that's okay. Otherwise,
सर
I'm
क्योंकि
planning
हमारी
to.
थेरेपी की क्लास है ना 4:50 पे, तो मैंने कहा कि अगर
That's
मेरा
why.
जवाब दे.
And that's why I thought कि it's difficult today. We can take tomorrow, and you also have the time to prepare.
सर
सर
कल ठीक.
सर
कल ले
टुमारो
लेते हैं
एज इन
11:30.
सैटरडे.
कल ले लें सर, कल ठीक है.
हाँ, 11:30 पे कल होगा, ठीक है?
हाँ,
11:30.
सर सर क्विज की टाइमिंग आप काइंडली रिकंसीडर कर सकते हैं, क्योंकि हमें टीम्स लोड होने में भी 5 मिनट लग जाते हैं, फिर हमें पीडीएफ बनानी होती है, उसे देन उसको अपलोड करना होता है, तो उसमें टीम्स लोड हो रही थी, क्योंकि अभी मैं 4G यूज कर रहा हूँ जोंग का, लेकिन स्टिल मुझे जो है ना स्पीड प्रॉब्लम आते हैं.
Right. Basically,
ये रैम
I
की वजह
select
से या जो भी है.
I select a very simple problem. If you know the concept, you can solve in 3 minutes, 5 minutes maximum. But I give you 15 minutes. I mean, for example, in last problem, that was just to calculate. I mean, in one of the problem, just to calculate two component. I mean, that was a axis. One of the axis was along the axis and one perpendicular to that axis, and one force was here. I mean, if you know the procedure, just 2 to 3 minutes, and I gave you 15 minutes. So similarly in the quiz, let's say if you say that the time is short, let's say I'll give you 15 minutes for the uh, solution, and then maybe 5 minutes to upload, right? So you have to prepare accordingly.
ओके सर. सर तो कल का टाइम ही बता दें कि कितना आप देंगे.
I mean 15 minutes for each question, and 5 minutes for the upload. So you can see 40 minutes, right?
ठीक है.
So
और
we'll
सर
start at sharp 11:30. So you have to ready at 11:30. Okay?
सर जो
ओके
आज
सर,
पढ़
तो
रहे हैं ये
कल
भी कल
क्लास
वाले
तो नहीं
क्विज में
होगी ना
शामिल
सर?
होगा?
जी?
सर कल क्लास होगी?
No, there will be no class.
ठीक है. और सर आज वाला लेक्चर शामिल होगा क्विज?
No, आज वाला नहीं होगा. Just chapter 2. We have completed chapter 2, so that will be just based on chapter 2.
Chapter 2 as in whole.
Yeah, as a whole. Right. So come back to this problem. So that means you can see weight is known. Weight is equal to 100 times 9.81. The remaining three forces are unknown. So we need to calculate these forces. So basically, first of all, we can convert each force into force vector. And how can we convert into force vector? We need a unit vector. For this one, the unit vector is already known. For example, spring ke liye we already know the spring unit vector. Unit vector is equal to I, because it lies on the x-axis. Similarly, for this force, how can we calculate the unit vector? Because we know the angle. So if you know the angle, calculating unit vector is very easy, because we know this is the alpha, this is gamma, this is beta. So that means calculating unit vector is very easy if you know these three angles, because that's equal to cos alpha I plus cos beta j, and then plus cos gamma k. So if you know the angle, you can very easily calculate the unit vector. But what about this force? Force FAD. For this one, the calculating the unit vector is not easy. First of all, you have to calculate the position vector. I mean this position vector. And how can you calculate position vector? The coordinates of A, and you must know the coordinates of D. What are the coordinates of A? 0, 0, 0. And what are the coordinates of D? I mean coordinates of D is, I mean you move from here 2 meter in y positive y direction, 1 meter in the negative x direction, then 2 meter in the positive k direction. So the coordinates of the C will be equal to -1, comma 2, comma 2. So now you can calculate the position vector of D, right? And then you can calculate the unit vector. I mean, if you divide the position vector with its magnitude, then you can get the position unit vector. So this is how you can now convert each force into vector force. right? So let's say this was the four forces. So the first force was FAB, so which was acting along the I direction. This is the N mean the Newton, this much Newton force which is acting along I direction. And then the second force was FC. So we know the angles. So if you know the angle, this is the unit vector, right? Unit vector, and if you multiply the unit vector with that force, it will become a vector force. So again, this is a vector force, this is a vector force. And then is the third force, right? Third force is FD. So for FD, you need again a unit vector, but we cannot get directly unit vector. We need first the position vector, and then you divide the position vector with its magnitude. So here is the position vector, you divide it with its magnitude, then you get the unit vector. So you multiply the unit vector with that force. Now this has become a force vector, and the force is the weight. We already know that weight is already acting in the z direction. So now the weight in terms of vector will be minus mgk. So minus mg mean minus 100 times 9.8 in the k direction. So now we have all the four forces. There were four forces. One is the non-force and three unknown forces. So that means all the four forces are in vector form. So now we can calculate the resultant force, right? Resultant force mean we can add up all the forces, right? So the resultant forces, right? Or in other word, in order to satisfy the situation of equilibrium, condition of equilibrium, then all the I component should be equal. We have to equate, right? And then the J component we have to equate, and then the K component we have to equate for all the four forces. In other words, the first condition was sum of all the Fx is equal to 0. So Fx means just the I component. For example, in the first case, this was the I component, FB. In the second case, the I component is minus 0.5 FC. Similarly, here is the I component, right? So in all the three equation, now you have three equation and three unknown. For example, three unknown mean FB, FC, and FD. So three equation and three unknown. So if you solve these unknown, I mean solve these unknown mean you know how to solve the simultaneous equation. If you solve these three equation, then you can get three forces. So these are the three forces. So once you get these three forces, can you get the spring constant? Because the second part was to calculate that stretch in that spring force. So we know the spring force, we just calculated that, which is FB spring force, and then the K value is given. So even we can calculate the stretch in the spring. So the stretch in the spring, because of that weight, was equal to 0.462 meter, right? So you got that, how to calculate the three-dimensional forces?
Yes, sir.
So point is that in three dimension, you have to convert all the forces in vectors. So we converted all the four forces into vectors, and then we apply these equilibrium condition, that I component first, and then the J component, this is J component, and then the K component. Then we three simultaneously equation, we solve that, and we got three unknowns. Let's try to calculate this one, 3-50. So here you can see the whole platform pump and motor. Let's say you want to shift that to somewhere, and here it is connected with, let's say this is the, let's say the crane, right, to carry the whole weight. So what is the whole weight? What is the whole weight? 3,500 pounds. Right? So the whole weight is basically this is acting in the downward direction, but that means whatever is the weight, that force should be equal to carry in the upward direction. So this is basically the total weight of that. The question is, calculate these unknown forces, that how much force will be acting in this string, how much force, I mean AB, then AC, then AD. So you have to calculate the unknown forces. So same procedure, that you have, let's say this is the force FB, FAB, let's say. So how can you get that force? First of all, you need a force vector. And how can you get that force vector? You have to multiply that force FAB with a unit vector. Then you can get a force vector. And how can you get a unit vector? Right? You can get a unit vector from the position vector. Position vector mean RBA, because this is acting in this direction. So yeah, that means you have to calculate the position vector RBA, right? B slash A. And then you have to divide with its magnitude to get that unit vector, right? And how you know that from position vector, since the position are given, so basically you need to calculate the position of each point. I mean the coordinates of each point. For example, what is the coordinates of A? What is the coordinates of A?
0, 0.
No, exactly.
10K.
What? Yeah, right.
0,
0,
0, 10.
yeah, 0, 0, 10. So these are the coordinates of A. Similarly, what is the coordinates of B? What is the coordinates of B?
8 in x direction.
No, you have to start from the origin. I mean, just like
3
for A,
minus 3, 0.
no,
3
that's, I mean, from here you have to move in the positive x direction. That's
4 minus
4,
3 and 0.
4, and then minus 3.
Minus
So 4 comma minus 3. Similarly, what are the coordinates of C? So you have to start from the origin. I mean, you move in the positive y direction and then positive x direction, right? So how much is the positive x direction? How much is positive x? Total is 4. And how much is d? D is 2 meters. So that
4
means
minus
2. 2 comma 3. 2 comma 3. And what is the coordinates of d? I mean, for d, you have to move in the positive y direction and then the negative x direction and then again negative y direction. So that means uh, minus 4 plus 2, right? So now you can easily get the position vector. So from position vector you divide with that magnitude, then you will get the unit vector. This is the way that you convert all the force vector into vectors, and then you apply the three condition of equilibrium. Let's say the first was FAB. So you multiply that FAB with the unit vector. So you got this force in terms of vector now, FAB. And then the second force, FAC. You multiply that force with the unit vector. So now you got that force in terms of vectors. And then you got the third force, FAD. You multiply that force with the unit vector. So now this is a um, vector force now. So the three forces, one force is already known to you, that was equal to 3,500, and that was acting in positive k direction. Now you have all the four forces, three unknown forces. Now you can apply the condition of equilibrium, which is sum of all the forces equal to 0. So now the three forces, I mean, if you sum up all the forces, now you have to equate the I component. I mean, sum of all the forces in x direction is equal to 0, sum of all the forces in y direction. So first, this is sum of all the forces in x direction equal to 0. So this term will be equal to 0. I mean, this is from here to here, that sum of all the forces in x direction is equal to 0, right? Similarly, this one is for the sum of forces in y direction is equal. So similarly, this is sum of all the forces in z direction is equal to 0. So these are the three equations. If you solve these three equations simultaneously, you will get these three unknown forces, right? So can you solve this problem? This is the same problem. Here just the angles are given. Alpha, beta, gamma is given. And here you will have three forces and one non-force. It's almost the same problem. So try to solve this. And please practice this problem. These problems are for 2 dimensions. This is for 3 dimension. Please try to practice as much as possible for chapter number 3. If you have any question, you can ask me. That clear?
Yes, sir. I will.
Yes, sir.
Excuse me, sir.